function. We just replace the sequence by the function. So what's the convergence of a sequence? We have an equal to L if and only if what? For all challenge given by U, because this guy is what? Is on natural number n, so I have a cut. Okay. That what? N larger than n implies near. Okay, I just write near. This is near. This is near. This part is this part. So basically what I change is the remaining part. So what does it mean? I have a function. This is, for some reason, this is 1.5. This is x. And I'm saying this fx at 1.5, due to some reason, I said it converts to pi. So I'm going to say what? Fx go to pi for x go to 1.5. So that means if my x near 1.5, it should converge to pi. Then what I'm going to do? I'm just going to do the same thing here. For any gap you give me, that means you disagree. You say that no, fx is not pi. For a bunch of stuff, that this is around 1.5, this means x around 1.5. You are saying that this value for x around 1.5 to the gap, that means the pi. You are saying no, they are not the same. So you are saying this. The distance between the limit I claim and the function value is larger than the gap or equal. Okay? Because if I have the equal to epsilon, that means I have a gap. Okay? And what I do is I disagree with you, so I negate this. Negate of larger than equal give me smaller than, right? So that's why you have a smaller than. So I just need to prove this is true. For what? For any challenge you give me. So the picture is like this, absolute value, right? This thing is a gap. So this y-axis, this part, is actually meaning this thing. This thing is within a gap, okay? The gap is given by you. Previously, in sequence, I have a cutting point n, and every sequence after this n, I have near. Now I'm not the same, because now I have x. X can be any real number. So instead of a particular location n, now I have to say what are the x value. So what are x value? This, what the heck is this? This means x near A. This means y near L. So this means near in the y-axis. This means x near in the x-axis. So I'm saying that from here, I have what? I also have a region. This is what? This is also near, right? This is also near, right? This means what? My f near my limit, which is pi. This means what? All the x in the x-axis near my particular funny 1.5. Okay, x near 1.5. How do you describe something is near? This is how you describe y-axis is near. Then how do you describe x-axis is near? You do the same thing, right? You cannot replace it with the same epsilon, so I write some symbol. I write delta. Okay? The reason why people write delta, because these two things both mean very small. And then what? I'm not talking about x-axis, right? So this is of course my x. And then what? This is the particular funny value, which is the 1.5 here. So I write this. So this is how you read this big chunk of thing. Let me recap. I claim my fx, x converge to A, has a limit L. Is defined as. For any challenge given by you, I disagree. I resolve your challenge. This big chunk of thing is I resolve your challenge. What challenge? You say there is a gap such that what I say is false. I say no. You give me a gap. I always say that these two subtract each other smaller than your gap, which is this thing. How do I claim this is true? I need to claim there exists some x that is true. That means what? There is a region in x within near my A. What's A? Limit go to limit near A. So I have a region near A. How do you describe what is near? This. How do you describe what is near? This. So these two numbers are like how near you are. So it means I have a region in X near my A leading to this. So in other words, I have a neighborhood in my X such that all your gap is false. I have everything here that f will have a smaller value to the limit than your gap. And this is true for any challenge you give me, then I beat it. So this thing is exactly the same thing as a sequence, but now I change to function. The only difference is for sequence, you have a index 1, 2, 3, 4, 5 because you have natural number. Now you have real number, you don't have 1, 2, 3, 4, 5, you don't have order because it's an uncountable infinite. So you have to use this, okay? This guy has to be larger than 0. If this guy is 0, that means you don't have a range of x. This guy has 0 sides, that means you don't have x, such that this is true. This is saying that I have a range of x, give me f within your gap. This point here, that means f at A is possible. This point does not exist. This function for x equal to 1 does not exist because you have something divided by 0. But limit at 1 exists. In other words, f has a limit, says nothing about the limit at that point have to exist. If I have a function that looks like this, okay, this guy, the limit, go to this particular value, let's say pi, so the limit go to pi, but it's possible f at this 1.5 does not exist. So it's not real number, it goes to infinity. Because this didn't say fa, right? Where is FA? There's no FA. So FA can be anywhere, including not exist. So that means limit of a function and the value of a function are two different things. If this limit and the value of function are equal, we said this function is continuous. So now I'm just saying limit of a function exists. I didn't say this function is continuous. This is the example. X cannot be 1. But limit of x equal to 1 exists. And you know how to find the limit. Okay. Now I have this. How do you calculate this? High school math. You just say, okay, 3 times 2 plus 1, 7. How do you prove this? Do this thing. That means you prove this sentence in the same sense as proving the sequence. You prove the long chunk of thing is true, then you have proved a limit exists and is equal to what you claim.